Alright, this is our horizontal metal cutting bandsaw. We use this for cutting a lot of structural steel and various shapes. We do not cut anything flat with it hardly. We don't cut sheet metal or flat stock with it. But we cut square tubing, angle iron. We do cut some flat bar. We can cut some round things with it, like round rod and round pipe and round tubing. So it has a lot of things that we can cut with this. It is water cooled. So right here we have a lubricant that we mix with some water, and that helps keep the blade cool and reduce the friction so that this thing can do its job. One thing that's really important to remember is we're cutting essentially steel with steel. You know, the blade here is a steel alloy, and then we're going to cut mild steel with that blade. So whenever you're cutting steel with steel, I mean, we're really pushing our limits of what we're trying to do. And in order to achieve the best results, we really have to follow a couple rules, and one of them is keeping some coolant flowing and on the part at all times. And it doesn't have to be a waterfall, it just has to be a nice consistent stream to keep it the part cool. If you see any smoking, that's instantly a sign that you're not getting enough coolant on the part. So this saw here is a pretty expensive saw, $3,300. We're really lucky to have it. The saw blades are quite pricey. And we're trying not to break the saw blade. So this one saw blade is around 80 to 100 bucks. And one student that isn't really paying attention or isn't doing what they're supposed to do can break that blade in just a fraction of a second. So we're really trying to do a good job with that. So this thing has a couple things. First of all, is the speed of the rotation, or the RPMs of the blade. So the blade is in a housing right here, and it goes all the way around back here and then comes back out. So it makes this big loop, and right here is the motor is in the back of the saw. And so we have like the RPMs of the motor. So it just depends where you're going to cut. Some things we're going to cut at a faster speed, some things we're going to cut at a slower speed. And that's the RPMs of the speed of the actual blade. And then the other factor we have is the feed rate. So that's how fast that the saw drops. So the way this works is the blade is spinning, and then the saw comes down with some gravity and then cuts through the part. So right here we have a little shock that basically just holds the head of this saw up until we release it, and then it slowly comes down. So there's a lever here. When you push this lever at 90 degrees, this stops it, and then when I lift it back up, it starts to drop. And then there's a dial on top, and I'll zoom in a minute and show you this, but this dial on top controls how fast it drops. So we need it to drop at the correct speed. Somebody has kind of damaged this a little bit, used to stay up just a little bit better. This right here is our table, so we have a table that we can put our parts in, and we can actually loosen this lever down here, and this whole saw head can turn at different angles. So we can do 45s and 20 degrees, 30 degrees, all kinds of different angles, which is really handy. There's a little degree marker down here that will help show us the angles, and it's a really good tool for that. So I can lock this back down, this lever, and I'll try to zoom in a little bit more and show you some of that in a second. Then I'm going to put my part in here, and the one thing to really remember with the saw is the part always has to be clamped for this to go well. If the part isn't clamped, it's going to move the part, and then it's going to break the blade. So right here we have a dial that I can turn, and it's going to clamp the part for me. The part has to be long enough to be clampable, so we're looking at probably at least a 6 to 8 inch part, so we can get the jaw on that part really well. So then, in order to actually make the cut, there's a series of things I need to do here, and one of them is turn the machine on. So right up here I have a power switch that I rotate, and it pulls it. As soon as I rotate it the direction of those arrows, it pulls out. And then I have to hit the green light. So right here's my speed for how fast my motor's going. Right now it's on a higher speed. And I can control that by moving this back and forth. This is like an all power button, and then here's my green. So when I turn this on, I'm going to start to get the coolant. It should start flowing. These control how much coolant is coming out. There's a pump in the back. That right back here is where the pump is, and all the coolant just dribbles down to the table, has a reservoir, and then recycles the water, the coolant again. So right now I probably have just a little too much coolant. I just need a really light, steady stream. Now I'm going to lift that up so the head's going to start to come down and make the cut. This is a little bit of a slow process. It's not the fastest metal cutting machine around. Alright, so I'm not going to reach in there and grab that until it's 100% done. That's really important that we wait just a little while. I'm going to kind of zoom in a little bit and show you some of these features just a little bit. Here, this is the lever that turns the feed rate off. So when this is up and I push this at 90 degrees here, it turns the feed rate off. If I lift that up, it starts to come down. This dial increases how fast it comes down. So if I go back up, all right, and I lift this up, I can make this drop faster or drop slower. I was a little bit quick on that cut. As soon as it broke through this part, it really started to drop. It's probably just a little fast for what we were trying to do. So then I can loosen my clamp and remove my part. There'll be some sharp edges. Should wear some gloves with this. Now if you're cutting multiple pieces like this, what sometimes happens is when the jaw clamps this, it actually clamps down here, but the top piece doesn't get clamped. So you can cut a big stack like this. It's actually a lot more efficient. But the problem is sometimes this top piece doesn't actually get clamped because there'll be like some debris in here, and the bottom one gets clamped. The bottom, maybe a couple do. Then when we're cutting, this piece flips up and snaps the blade. So you'll see this one has some saran wrap on it. It's kind of holding the pieces together in a unit. So that way when I'm cutting this piece, when I clamp it, I know it's going to hold them all together because there's another source of clamp behind it. And another option, instead of there's just some saran wrap already on these pieces, but you could put a C-clamp back here on the back part, and that would hold it as well. So the C-clamp would make a big difference on how well that goes with that. So I'm going to show you the coolant reservoir tray a little bit more. So here is the coolant pump, and this is the tray that recirculates the coolant as it collects it. There's a little bit of a filter that filters it back up. Over here is another look at a couple features over here. This is the lock that locks and unlocks the head of the machine. So I'm going to lift this back up. Okay, and I can move it over now. So this lock puts it at the different degrees. Right here is a reading of the degrees, so I can look in there and see. It's not a bad idea to still double check your angle. Right here's my clamp that loosens it and tightens it. This is like another type of clamp. If I loosen and tighten it with this up, all right, then I push this down, that just clamps it all the further. So just to show you this again, this is like a clamp just to help you tighten this to the next level. So I get this snug, this has to be up, get this snug, then push this down, and that kind of locks the clamp, so to speak. So watch me do that again. It's up right now, and then I just snug the part, and then I push down, and then that locks it. It gives it like the second power, so to speak, of clamping that. Safety-wise, a couple big things on this is just keeping your hands back when it's cutting, clamping your work spot, your work piece, not cutting anything too small, and making sure you're cutting at a safe speed and a safe feed rate. So those are some things that I can help you with. You can tell me what some of those are, or I can help tell you what some of those are. Right here, this is the gauges measuring the tension on the blade. So this dial here adjusts the tension of the blade, and I've actually taken the handles off because I don't want you to adjust the tension of the blade. I've already done that. And before, when I left the handles on, kids would turn this thinking they were turning this, and it'd cause a lot of problems. So right now, if I look at this, I'm right in the green of where I want to be on my blade tension. It looks like I could tighten it up just a tiny bit, but that is pretty much where I want to be. It'd be great if after you're making some cuts, if you could clean this area up, scrape some of this into the metal bin and any waste products that you could pick up, we'd really appreciate it. Another thing is we can take a wire wheel and brush some of this debris off, and then it'll cut just a little bit better. So when you go to cut angle iron on this, one really important thing is that when you cut the angle iron on, the angle will be down. If I grab a piece of angle iron, I'll show you. So here's a piece of angle iron. I'm going to slide it through here. Whenever you cut angle iron with this, it gets cut down in this position. So if you cut multiple pieces, then you would put a clamp on there. But that is the safest way to cut angle iron. When we have it up going the other way, it tends to really be extra hard on the blade of what we're trying to do. So unless I have to cut a 45, then I'm going to have to stand it up. But if we're just cutting angle iron straight off, this is the way that I want you to do that. If you have any questions on this machine, make sure you ask before you use it. You have to pass the safety test with 100% and let the instructor watch you use it a couple times